In today's class, we'll be looking at the teacher's guide to volumetric analysis for the 2025 NECO chemistry practicals. Please note that this video is a teacher's guide. Now, solution A is the acidic solution, while solution B is the alkaline solution. From the instructions you have received, solution A should contain 6.30 cm³ of HNO3 per dm cube, while solution B is a mixture of Na2CO3 and NaNO3. That is a mixture of sodium trioxocarbonate 4 and sodium nitrate. Please note that you are not expected to prepare two different solutions. Solution B is expected to contain these two compounds. It is expected to contain 5.5 grams of Na2CO3 and 2.5 grams of NaNO3 per dm cube. So you have this entire mixture in 1000 cm³. Now let's look at the unique characteristics of these two compounds. Na2CO3 is a product of the reaction between a strong base and a weak acid. The strong base here is sodium hydroxide reacting with a weak acid, which is carbonic acid, and this gives us Na2CO3 plus H2O. Now Na2CO3 in its anhydrous form is neutral. However, in its aqueous form, it is alkaline because it is the salt produced from the reaction between a strong base and a weak acid. So take note of that. Now NaNO3, sodium nitrate, on the other hand, is stable. And aside from the fact that it is stable, it is neutral. So in this mixture, NaNO3 is neutral. Now let's consider the possible reactions we may have during the titration. If I have HNO3 reacting with sodium trioxocarbonate 4, the result is going to be sodium nitrate plus water plus carbon dioxide. And in balancing this equation, I have 2 sodium here to give me 2 NaNO3, and I have 2 hydrogen atoms here to balance up this equation. Another possible reaction is HNO3 plus NaNO3, and in this case there is no reaction. Then the third possible reaction is we may have HNO3 reacting with this mixture. However, in this mixture, this is the compound that will react or neutralize HNO3, and at the end of the day we have NaNO3 plus H2O plus CO2. In balancing this now, I would have 2 HNO3 here and 3 NaNO3. Now this means that the acid to base ratio is going to be 2:1. That will be the acid to base ratio. Na is equal to 2, Nb is equal to 1. Now with these parameters, there are some other things we can deduce and that will help us in solving questions that may come up in this year's NECO exams. Now recall that solution A has already been given, and the initial volume of solution A is 6.30. Therefore, it means that V1 is 6.30. We are expected to make it up to 1000 cm³, which implies that V2 is 1000 cm³. On the other hand, for concentration of solution A, which is nitric acid, the initial concentration is 15.8 molar, and you can check this on the internet, while the concentration which we are expected to look out for is C2. Therefore, C2 is unknown. Now, using the dilution formula, C1V1 is equal to C2V2, I have C2 is equal to C1V1 over V2. Therefore, C2 is equal to C1 is 15.8 times V1 is 6.3 divided by V2 is 1000. Therefore, C2 is equal to 0.0995 molar. This C2 is Ca. Therefore, Ca is equal to 0.0995 moles per dm cube. We can also estimate the concentration of solution B using this formula. We know that N equal to Cv, where N is the amount, C is the concentration, and V is the volume in dm cube. Therefore, if N equal to Cv, we also know that N is equal to mass all over molar mass. Recall that the main compound reacting in solution B is sodium trioxocarbonate 4. Now, the molar mass of sodium trioxocarbonate 4 is 106, while the mass as given in the instruction is 5.5. Therefore, N is equal to 5.5 divided by 106. And this gives us 0.052 moles, which implies that there are 0.052 moles in 1 dm cube. So the concentration becomes 0.052 mole per dm cube. So far, our estimated concentration of A is 0.0995 moles per dm cube, while our estimated concentration of B is 0.052 moles per dm cube. Now, from these parameters and values we've gotten so far, how do we estimate the volume of acid that is needed for the neutralization reaction? Now, recall that Ca Va over Cb Vb is equal to Na over Nb. From all that we've gotten so far, Ca is equal to 0.0995. Va is what we are trying to estimate. Cb is equal to 0.052. Vb is 25.0, which is gotten from the volume of the pipette. Na is 2 and Nb is 1. Now I'm going ahead to substitute and look for the value of Va. I have Va is equal to, now Va is equal to Cb Vb Na over Canb. Therefore, Va is equal to Cb is 0.052 times Vb is 25 times Na is 2 divided by Ca is 0.0995 times Nb is 1. Therefore, Va is equal to 26.05 cm cube. Therefore, my average volume of acid used would be around the range of 26. This means that values that are a little below 26 and values that are a little above 26 are acceptable. But remember that you are supposed to work with the instructions sent to your school and make sure you fill your average volume of acid used in the report that has been sent to you. Now, here are some possible questions we may also look at. Number 1, calculate the concentration of A in mole per dm cube. Number 2, calculate the concentration of B in mole per dm cube. Number 3, calculate the amount of acid in the average volume of A used. Number 4, calculate the amount of trioxocarbonate 4 in the volume of B used. Number 5, calculate the mole ratio of A to B. Number 6, calculate the volume of CO2 evolved at STP.